Merhaba arkadaşlar. So last time, if you remember, we had a quiz. The quiz question was something like this. Suppose we need to design classes to represent types of employees, and then there are basically three types of employees. One was the regular employee, which has the public instance variables for name, address, and then the TC kimlik number, and also we had the the pay, which is basically a double, which indicates the pay rate of the specific employee. So basically the name, address, and the TC number is going to be represented using a string. However, for the pay rate, we had the double representing the employee, and then you had a manager. That's again an employee of the company. However, it has specific properties with maintaining a number of employees that is working under him or her. And then we have another type of employee, which is a volunteer and who doesn't get paid for the work that he or she is doing. And in the question, if you remember, you were asked to write public methods for accessing employees' salary. Also, the specific salaries were given. For a regular salary, the amount of payment or the salary would be whatever that pay rate is. And then for a manager, on top of the pay rate, he or she is going to get an additional 10% per employee he or she manages. And so if obviously no bonus if there isn't anybody working under them. And also the third, volunteer obviously doesn't get any payment. So how are we going to design such a class hierarchy? So basically you can think of this as a hierarchy where you have a base class, right? What's the base class here? Employee would be the base class, and then your manager and your volunteer will extend whatever employee implements. So if you look into here, for the employee, you will have basically the instance variables are already identified for you. Name, address, TC number, and then you have the pay rate. So those are the four instance variables you would need for the employee. However, for the manager, do you need anything in addition to the employee? So yeah, in order to keep track of how many employees he's managing or she's managing, you need to keep track of another integer variable to start with. So you have to have an additional variable, instance variable, on top of the employee property. What else do you need to implement within employee class, within the employee class in terms of methods? So you will have, as they have indicated here, public methods for accessing an employee's salary. So you will have for example, get salary method, which is basically going to return the pay rate of the employee on the base case. However, if you have the manager that's going to extend what is implemented in the employee, in that case you will modify the method that's giving the get salary, right? So how are you going to modify? Basically you're going to override whatever is implemented in the employee. In manager, you will call it in a different way, such that you access the base salary plus the 10% times the number of employees he or she is managing. And then the third volunteer, you will again override the employee's salary such that it is going to return basically zero. So if it's a volunteer, it's not going to get paid. He or she is not going to get paid, and in that case you'll just override that method. And if you look into the basic implementation, this is written wrong here. It should be private, because we want to design it in that way. So you have the class employee, and in that case you have private all these instance variables, and then you have the pay, which is again the amount of payment or the pay rate that the employee is going to get, and then your method public double salary, which returns the pay amount, the pay rate of the specific employee. This is the base cases employees salary method. And then once you have the volunteer, class volunteer extends employee, so it is going to inherit all the properties of employee. On top of that, you will modify or override the salary method, in which case you will have return 0 for the overridden method. Okay, any question?
Return edebiliyor muyuz? Mesela return salary deyip öyle bir şey yapabilir miyim?
You mean here or in the volunteer class?
İkisinde de değil hocam. Normalde mesela return deyip metodu çağırabiliyor muyuz?
If you need to use the method name, you can use the method name with the object. So if you have a let's say I have employee A, new employee, right? So I created the employee object, and then once I created that, I can call this with A, and then whatever that method is, in this case salary, A.salary will return me a what value? Obviously, it will return me a double value, right? So if you want to assign this to a double X, you can use this. Or if you want to return this value within a method, I don't know why you want to do that, but if you want to do it, you can do that if this specific method that you have written returns a double value at the end. So if you have a method that does something like this, public, double a method, and then you take an object of employee A. So basically, not a really useful method, but if you want to, you can use it to return the objects which is passed as an employee, and you can access its salary method and return it. Is this what actually you are asking?
Normalde hocam hani obje yaratmadan direkt burada mesela hani bir metod oluşturacağım ve diyeceğim ki return işte salary'e dönecek. Hani böyle bir şey mümkün değil mi? Hani ben şunu yapmak istedim. Hani her bu metodu çağırdığımda üçünün birden hani maaşını görebilelim diye.
So in this case, you will have 3 different classes of objects, one for this, one for that, and one for that. If you want to use this salary method within the implementation of this call, you can do that. However, if you want to use it here, you can also use that there, but I don't exactly understand the question, I think. So when you look into the manager, you can also implement the manager by extending the employee. In addition to the instance variables of the base class, I will have an additional instance variable, public int employee number, and then I'm going to get the salary by using the super.salary, which is going to basically call the base method salary, and then whatever is returned there, I will use that and then multiply this with 1 plus, which is the base salary, plus the 10% employee number per employee that I'm going to get a bonus for. In this case, you can use, because since it's defined as public, you could immediately, use pay, and it will be able to access. However, if it was private, you wouldn't be able to access it. If it was protected, you could have also used pay again, but it depends on how you define it. Yes, you can use the super to refer. No, you cannot access the private variable by using the super as well. You cannot access. In this case, it would be okay, but if it was private, as it should be, or protected at least, it wouldn't be possible if it was private.
Hocam, o private olsaydı, employee'de bir tane public method yapıp içine onu atıp daha sonra o public.
Obviously, you could, if you had the get methods, you could have easily accessed them, which was the proper way to do it. But since I didn't want to have, lots of things on the slide, it's just whatever is needed here. Okay, so there will be definitely a question in the exam to design a class with given for a specific hierarchy. How would you design your classes and objects? So you be careful and try to test yourselves by implementing different class hierarchies that you can think of, such as shapes or animals, I don't know, cars, whatever you can think of. Go ahead and try to implement a couple of problems by yourself and try to see how the classes behave. It will give you a lot of experience, and you will be able to answer the questions that comes from this topic. So going back, any other question? Again, identifying the features of the classes is important. So going back to the last part of chapter 8 slides. If you remember last time, I mentioned to you the abstract classes. What was the difference between an abstract class and interface? In interface, all the methods are abstract methods. So if you remember, we said that we have abstract classes and interfaces. What was the difference between an interface and an abstract class? In interface, you have all the methods as abstract. So you do not give any definition of the method that you have in the interface. However, in abstract class, you have some methods as defined as abstract and some others as non-abstract methods. If you do not specify the keyword abstract, it is going to be considered as a non-abstract method. Otherwise, it will be considered as an abstract method, right? So if you use inheritance in in your implementation, you should be trying to come up with a design where you have inheritance implemented such that you have the base class that has the common characteristics, and then the subclasses or the childs of this parent class will have the certain methods that are not implemented, or the methods that you want to override within the base class. So you are going to, as you go from top to lower levels, you will have additional methods, additional instance variables that are going to be specific for the child. So you have the parent, and then you have the childs, which are going to be the children, which are going to be basically using the things that are available here, and they will have their specific own things that are not available within the base class. So you should, if you obey on the rules of inheritance, you will be able to come up with a good design of class hierarchy. And if you remember, the certain things that you need to pay attention are every derivation should be an is-a relationship. So you should use inheritance in an is-a relationship type, parent and child. And also, if you want to find common characteristics of classes and push them as high in the class hierarchy as possible, and override the methods as appropriate to tailor the functionality of a child. So you should override the methods of the things that are possible to override and that you have different meanings in your children. And add new variables to the children, as I said earlier, if it is better to do so. And whenever you have a subclass in your constructor, you should first call the super method such that you first create the parent object, and then from that point on you create the child. So the first method call of your constructor in your child should be a super call, which is going to basically first create the parent object, and then you will go into rest of the remaining parts of the child. Okay? So you will have, if you have a constructor, the first thing that you will call is super with whatever the arguments are. And then it's always good to have the toString and equals methods to to have the class ready for implementing additional things. And abstract classes are used to represent, as we said earlier, to represent general idea of subclasses. However, you will not have an instance object of an abstract class. So if I have an abstract class, such as we did with the body, if you remember, we have the example. What was the example? Public abstract class body, right? And in this class I had certain private, right, double density equals 1 was one of the instance variables I had in this class, and so on. So I had the definition of the class. So if I want to create a object of type body, body A, new body, would that be possible? It's not possible because this is not a fully implemented class. It's just an abstract class which is going to be used to create children from. Okay, so you can never instantiate an abstract class. You can never have an object of an abstract class. So all the abstract classes will be used for implementing other classes within. So that you, if you remember, we had the body, and then we had the sphere body, right? And we had the, what was the other one? Cube body. So basically this is used for collecting the common information on an abstract class. However, it cannot be instantiated as an object. But these could be obviously instantiated because they are not, abstract classes. They are just regular classes which extend the body. Any question? If you wanted to create an object like this, you will get a compiler error.
Mesela normal bir class yazsak, böyle bir tane rastgele bir metodun abstract class'ı da abstract yapsak, onun şeyini tanımlayamayacağız mı yani?
If the class is abstract, you cannot instantiate an object from. Okay. That abstract means it's going to create you an abstraction. So it's not for the purpose of instantiating an object for. So you have to extend this body into whatever you have to do. After that, you create another class which implements all the methods that are available as abstracts here, and then you can use and create an object for. So if you want to restrict the inheritance, you will use the final. So if I say, hey, I have a class public final class and then body, and I have the certain methods and instance variables, then it is not possible to extend this class at all. So any other class will not be able to write something like public, public and then class A extends body. This will not be possible since this is identified as final, which indicates that this class is not used for inheritance, and it cannot be inherited and used as a parent class for the other children. So that's important. And also, if you want to prevent overriding some of the methods of your base class, you can also do that by writing a final as the modifier for your method. So if I have, let's say this is not a final class, but it's public class body, this is just a regular class. However, I have a method that gives me, let's say, public double get density. And then I have certain statements within this method. So it returns me the density of the body. And this is a regular class, not an abstract, not a final or so. However, if I want to prevent this method to be overridden by the subclasses or children, what would I do is that I will add a final keyword here so that it's going to prevent this method to be overridden. So nobody else, the children, will not be able to override this method, and this is going to be the final form of my method. Okay? Any question?
Hocam mesela bir class tanımlamak istiyorsunuz ve bu class'ın belirli bir sayıda subclass'lar olmasını istiyorsunuz. Subclass olsun ama belli bir limiti geçmesin. Onu nasıl tanımlarsınız?
I don't think there is a specific way to limit the number of classes that a parent class will have as subclasses. So there isn't, in terms of the number of classes that you can limit, I don't think there's a way to do it in Java. So obviously an abstract class cannot be declared as final. Why? An abstract class cannot be defined as final. The reason for an abstract class to be there is because to extend it, right? So why define it as final if it's going to be extended anyway? So an abstract class cannot be declared as final is a rule also. So if you consider the GUI components, all the GUI components actually use the inheritance properties. So they come up with a object hierarchy. So when you look into the Swing components, they are usually derived from the JComponent, which is actually a part of container and which is part of component. So component is the parent of container, which is parent of JComponent. And whenever you have, let's say, JLabel, it's part of JComponent. So it's basically a hierarchy that you are following. And then whenever you, let's say, call the paint component, if you remember, you were writing the paint component for certain, panels and things like those. What do you do when you call when you write the paint component method? You're basically overriding the paint component of the J component or paint component of the container and all the way to the component. So each one of them is overriding one other's paint component, and then the last thing that you do is to override the J, for example, JLabel. If you remember JPanel, so you were extending the JPanel. Remember the classes that we have written, right? We were saying that those panels such as, what was that? Rubber lines panel extends JPanel. So what you do here is that JPanel has a method that gives you the paint component. This is a method defined in JPanel, and then whenever you write this paint component method, you are basically overriding the JPanel's paint component. If you recall, in our paint component method, the first line of the code was what? Super.paint component. So we basically, get the things necessary done by the JPanel first, and then our additional things were coming afterwards. So this is basically exactly the same as what is done in inheritance. So you use the methods that are available within the GUI components, and they are used over and over by subclasses and children. So if you look into the overall Java, object hierarchy, you will see that it's a really big structure with lots of trees and going downwards with leaves, a lot of leaves. So and many of the components that you see are also derived from the container class, such as the JLabel. For example, in a JLabel you can add image icon. If you recall, we had the label on top of the figure in an image icon, which is basically because JLabel is within the container, so it can contain things within that class. Again, also in applet, so we were using the applet class or the JApplet in our implementation. So basically, what we were doing there was again the calling with the paint component. We have the applet class implementing all the necessary stuff for us, such as the interaction with the web browser, taking care of encryption, and all those kind of things are done already by the applet, and we use that to derive our own class to implement things that are that we would like to implement. So inheritance is all over the Java library, so you can see it. And as again, when we define paint component method of an applet, we're actually overriding a method defined originally in the JComponent class and then inherited by the JApplet. So JComponent has this paint component, and then which was overridden by the JApplet, and we override that method as well. So that's basically following the same tree of the hierarchy in the inheritance. So if you recall, we have used the MouseListener events. What was the MouseListener? It was an interface which provides those 5 methods that if you want to implement the MouseListener, you will be implementing, right? Whichever you like to implement. However, in some of these methods we were not using at all, right? So if you recall, we had the MouseListener. We were saying our class implements MouseListener, so that within our implementation we had all those 5 methods that are mouse clicked, mouse, pressed, mouse released, and all those events were, all those methods were listed here as 5 of those we had to have them. Even though we didn't implement the internal implementation, we had to have the name. However, this mouse adapter class gives you an elevation to this. How does it give this elevation? Basically, what you do is instead of you are implementing the MouseListener, basically mouse, what was the name? Mouse adapter implements the MouseListener. So they are actually writing all these methods. However, all of these methods are empty. Okay? So all these methods are empty, such as mouse pressed, and so on. All of them are empty methods. So whenever you extend this, so how are you going to extend? Let's say you have a method .listener, right? Public class .listener. What is it going to do? Extends mouse adapter. What this provides you is that if you are going to implement only one of the methods, such as the mouse pressed, I will just implement this method because I'm overriding whatever mouse pressed does here. So since it was already empty, it's basically going to be overriding this method, and I will be only able to write that, and that will be sufficient, so that I don't need to write the remaining 4 methods as empty methods at all. Okay, so this elevates the problem of writing all those empty methods. You'll just add only one method that you want to modify. If you have 2 methods that you would like to override, you will write those 2. So this is just giving you an easier implementation. Rather than implementing the MouseListener, you can extend the mouse adapter such that you only implement whatever method that you need to implement. Is everybody understanding what's going on here? So it's a same exact thing, except that I don't need to write these additional empty method calls at all. So I just write whatever I need here. So let's look into the off-center example here. So basically, whenever I double click here, it's going to get the current point. How does it perform this? So it uses mouse click actually, and with the clicks, what happens is that it initially draws this empty circle for the center, and then once with my click, it gets the current point that the event happened where the mouse click actually happened. And it basically draws the line from this point to this point, and then gets the distance, calculates the distance, which is basically, getting the differences on X and the differences on Y, and, calculating the diagonal of the triangle. And then it prints that on the screen. So that's basically, with every click, what happens, it repaints everything from scratch so that it gets the, the distance based on my clicks. So if you look into the code, you see that this is the same panel, same exact thing as before. I'm not going to talk about that. And if you look into here, you have the constant values, width and height by 300, 300. And you have the center X, center Y, indicating the current center, and the point, which gets the current click point. And double length returns the difference between the points. Public off-center panel. Add MouseListener, so if there's a mouse event happens, then my off-center listener object will listen to it, and then it will take the necessary action according to the event that is happening in the mouse. And initially I set the center point to width divided by 2 and height divided by 2, so that I get the center point of the square. and this is the format that is going to be printed for the number on the distance, and the yellow color and the sizes also set there. And when you look into the mouse click event, so this is what exactly I was just trying to explain you. Private class off-center listener extends mouse adapter. So it doesn't implement mouse listener, but it extends mouse adapter, which basically only implements this method, since the other methods are already implemented by mouse adapter, which are all empty. Okay? So basically, I get the current point with the mouse click event get point, so I know the x and y coordinates, and then I get the length by mat square root and take the current x minus the center location of my coordinate and take the square of it, and similarly for y. So I get the distance between the 2 points, and then what do I do with every click? I will repaint everything from scratch. So if I go here in the paint component, this is what I was referring to. So the parent class, which is JPanel, is going to be getting things ready for the JPanel, and then on top of that I set my color to black, and then draw this small circle, right? So you have draw oval, center x minus 3, center y minus 3, and then 6 by 6 small square. And if the current point is not null, meaning that if there's a click, then in that case you're going to basically draw the line and change the distance label to be the correct value for the current distance. Okay, any question? So basically I could just change this to something like this, implements, right? And then mouse listener. However, it's going to give me an error, right? Because doesn't override abstract method. Doesn't override abstract method mouse exited, and all the other mouse events need to be implemented in order to implement the mouse listener, right? So I will need to have those empty methods added into my class. Okay. So this is related to the event adapter classes. So you have also the key adapter, which is going to do the same thing for key events. So you don't need to use all those key methods. Instead of that, you can use key adapter to do the same thing for the key events. Okay. Timer class, as the name suggests, that you keep track of the timer by using a start and stop, so that you have a timer that you can use for, and which is going to basically, the timer object generates an action event at specified time interval. So you give the time interval and it generates you an event saying that, hey, the time has expired, do whatever you need to do. So that's basically the job of the timer class. And if you look into that, you have the start and stop methods. Let me give you this example, the rebound. Where's the... Again, rebound class just uses this rebound panel, and it creates the rebound panel and adds it to the frame. When you go into the rebound panel, it again extends the J panel, so it's going to have these width and height. Let me first execute this, it will be better. Obviously not this one. So this is what is happening with the rebound. So how is this achieved? So basically what you have is a if this is your panel, right, you start at a certain point, and then after, this is your happy face, right? After a certain time delay, in this case it is 20 milliseconds, it's set to 20 milliseconds, it moves to, if you recall, if you look into the first starting point, it goes from here to this way. So that's where it starts actually. And the new point is going to be indicated by, this is, if you recall, x in positive direction, and this is y in positive direction. So you have the 0, 0 coordinate on the center, on the left topmost corner. And with every move, with every 20 milliseconds, what's going to happen is that it is going to increment this both x and y of the face, happy face, with that specific value. Let's say you set it to 5. Every time it will move 5 pixels to bottom and right side. So it's going to update the x and, let's say initially the values are kept in x and y. The next time you will update your x to be x plus equals 5 and then y plus equals 5. However, you will reach, whenever you reach here, you'll need to update your direction such that since you reach the boundary, you will move upwards instead of downwards. So what's going to happen is that in this case you will, what are you going to do? You will subtract 5 from the value. And then similarly, if you go, this will make you move this way, right? And then whenever you reach to the boundary on the y, on the x dimension, what's going to happen is that you will just update your, this one was supposed to be y actually. The updated value will be related to y. When you reach to the right hand side, x is going to be needed to -5 so that you will, go from here to there and so on. So you have to check the boundaries for conditions whether you reach the ends. So if you look into the code, yes, you can enlarge the panel, but what's going to happen is that it will move around the same panel it started with, because it basically doesn't care about the size of the current panel. What it cares is, what is specified initially to the object. So it's given as, if you look into the code, you will be able to understand the reason. So basically, width and height is initially set to 300 by 100. So it's basically looking into these values. It doesn't care about the current size of the panel. So delay is set to 20. So if I set it to 200, you will be able to see it in a better fashion. So let me, basically what happens is that you repaint this at every 200 milliseconds now. So let's execute this. So as you see, every repaint operation can be seen by this slow motion. So if you just want to make it faster, you can do that too. If you look into here, the width and height is given initially, and then I have this new timer. So basically, this is the timer object that you create. You give a delay, which tells you how many milliseconds you're going to generate an event. And the generated event will be sent to this rebound listener, which is going to be the listening object of this event. So whenever my timer fires that, hey, my time is up, it's going to basically go and warn this object so that it will perform the action that is related to the object. And you have the happy face image that is extracted as an image. And you have the initial coordinates with 0 by 40. And the pixels to move in x and y directions are set to both 3. So it will move in differences of 3 pixels each. And it starts the timer, and then, once it's constructed, it starts the initial execution. And when you look into the action performed, this is the rebound listener. So this is the listener that listens to the events of the timer. So whenever the time expires, it's basically going to perform this action performed method. In which case, you update x and y with move x and move y. And if you look into the remaining part, this is explaining the boundary conditions, right? If my x is less than 0, or if my x is greater than width minus image size. So if I have reached this boundary or that boundary, I will change my direction. How do I change my direction? Whatever is my current direction, it could be +3 or -3, I will update it with the corresponding one. If I'm going this way and I have reached here, then that means I was using +3s. Since I will need to reverse back to this direction, then in that case I'll just multiply 3 by -1 so that I will have -3s the next time it's going to go this way. And similarly, if I reach here, that means I'm going with -3's, since I'm subtracting the x. I will multiply it with -1 such that it's going to rotate and reverse the motion towards this direction. So it will be 3. And that's why you have move x multiplied by -1. And same for the same reason, you have move y multiplied by -1. And every time you add this move x, whether it's a negative or positive value, to the current x and y values. And then obviously you call the repaint method to repaint everything so that it's going to basically paint the image to the xy coordinates, the current xy coordinates of the image that I have. So at every 20 milliseconds, it's going to basically update the image on the screen. Any question? So chapter 8 focused on basically the new classes and how to use existing classes in terms of inheritance. And then we have used the protected identifier for things that we would like to use in our subclasses or children. And then we have talked about the abstract classes, their differences with the interfaces. And also, how to use inheritance in our design of the object-oriented programming applications. So also we have covered the GUI components with the timer. Again, we will have questions related to abstract classes, interfaces, the protected modifier, and overall object-oriented inheritance design in the exam. So get ready in terms of these topics. So the exam covers up to the end of chapter 8 as it is announced on the web page. So beyond this point, we will not be, you will not be responsible in the exam. However, we will obviously deal with those in the final as well. So any question? Okay, let's give a break and then we'll continue.